A quick intro. My name is Nirav Shah. I'm the BMC Firmware Architect at Intel.
My name is Jason Bills. I'm a senior BMC firmware developer at Intel.
To ground the discussion a little bit, what we did is we want to start with some info. We want to say that all the information that we have gathered for this presentation, it's all sourced through AI, all open, available at the internet. This is not an Intel statement. This is us, the two of us, talking about OpenBMC and where we would like OpenBMC to be and what we should do next. At the same time, I think we just have 4 slides. We want this to be an open discussion. So please interrupt if you would like to wait at the end and ask questions, or if you have comments, or if you violently disagree, like I'm guessing Ed would. That's fine. I think that's what we want, is we want a discussion. We want to call out this as a opportunity, and we want to see what we can do together. That's the goal.
Sure, I can just start. So something that we've been looking at, and it was on what Patrick talked about this morning also, is kind of this S-curve idea, which is interesting, that we kind of looked at some of the changes of the BMC firmware over time, and it also about every decade seemed to jump. So we looked back in the history a little bit and saw that can't read the numbers on the little screen. In 1998, IPMI came about, and a few years after that, we see a proliferation of some major vendor BMCs based around IPMI. About a decade later, PMCI was founded, and within a few years after that, we see some standards come from that group that are another kind of big effort that hit. And then again, a little bit less than a decade later, we see OpenBMC come into the picture. And within a few years of that, another big jump in development effort and proliferation of some technologies that came from that milestone.
Yeah, I think Jason is perfectly right. And I think this is what Patrick referred to as well. I think what we're trying to say here is, even if you go back before IPMI into the KCS days, this trend carries, and history repeats itself, right? Actually, the problem is, and the good thing about this way, the S-curve idea, was that we were able to organically grow, and we could have on the downturns catch the effort behind it and have the architecture catch up. So it was not a scalability problem. Although at the same time, it was more of a bottoms up effort. It was not so much of a top-down effort going in, architecturally at least. So that helped a lot. I think 20 is an exception. I know, Patrick, you mentioned that we are in this era of the BMC settling down. I think based on the data, at least for the next slide, I think we disagree. I think what we are seeing is a lot of specs coming in, at least from the spec direction. So let's jump into that. So again, we cannot talk about DMTF openly. We have to be within the DMTF forums to talk about it. We can't talk about OCP openly in some cases, but all of this data is openly sourced. It's available on the public websites. It's just calling out the various specifications that will touch the BMC pretty exuberantly, and they are something that we have to deal with, right? SPDM, we have talked about it since morning a lot, and I didn't plan that. It's on the top, but I didn't plan that. PLDM for firmware update is a very important use case. 1.3 for PLDM type 2, I think it's a very, very important spec, especially because of the way the PDRs are listed, the way file descriptors are described in the PDRs. I think this is the one that makes the type 7 possible, the file IO possible. So it is also an important step in the direction of kind of adding new features into the BMC. Through data specification, and this is awesome because I think we as an industry across the board agree we don't want IPMI. We want to move away from it. But we don't. And today there are a lot of devices out there from Intel, from other vendors, from the overall ecosystem that support through from IPMI. There is no other option. And I believe recently we put a workaround for the date wrap in IPMI for the fru data. So we are maintaining it, whether we like it or not. It's there. Although DMTF has gone through the effort of defining 2 more specifications, one for the data model, which is the 220, the fru data specification, and then PLDM type 4 has added support for removing I2C, using the use of I2C to communicate with the EEPROM. So it's more of the vision of the future, but all of these things are coming at once together. There was a conversation about OBMF. I think Ed brought that up as a vision for USB. I think USB is right up there as well. So all of these things are hitting us all at once, and we need to be prepared for it. Coming on the OCP side, I think there was mention of OCP historically being, at least in the first decade, being more of a hardware-focused specification forum. But over the last, I want to say 4 or 5 years, there has been a lot of evolution as far as BMC goes. There are a bunch of these OCP GPU and accelerator specifications that have come out that are at various stages. Some of them are at 1.0, some of them are at 1.7. There is the management specification, the OEM specification. I didn't mention the SMC specification, but it's also one of the things that OCP has published. Calyptra, I think, designing something for at least a post CSNA 2.0 environment. One thing good that the government has done, and it's hard to find across the board any government doing great things in technology, but one thing good that the government has done is define a white paper and called it to a CSNA 2.0, where they've clearly said, we give you until 2027 to move on from traditional ECDSA algorithms and get to PQC. And SPDM 1.4 and Calyptra 2.1 are major milestones in that area. And all of that is hitting us, right? RAS API, this is personally closer to myself as well. I've contributed a little bit to it. It's also something where I think from a customer perspective, I know on the Meta slide and also on the Microsoft side, there was conversation about error handling and how we can do better and how we can standardize and not have vendor-specific code for that. I think RAS API is a good step in that direction. And yes, it's hitting the BMC. So I think from looking at this, I don't know, I think we are in a BMC bubble is what I would say, right? All of this is simultaneously hitting us in this next 2-3 years. That's what I feel. There is the OBMF standard that is looking at supporting boot related features using USB, which is not traditional. And that is hitting us pretty soon as well. I appreciate that. And then I'm gonna have you stick with that agreement for the next few slides too, because here's where we come up with a roadmap to how to solve that problem.
Yeah, so I think, are we going to the next slide? We can go to the next. No, I was just going to say, I think, even if this isn't revolutionary, it looks a little scary. But there's a lot of really good people in this room, and a lot of really good people online, and a lot of really good people in the community, and I think we can make it happen. You want to say something, or go next slide? This actually wasn't my slide.
Okay, I can take over it. No, and I think just to add that, I think the scary part isn't that we have to do all this work. We are engineers, we want to do all the work, right? The scary part is all of this is an opportunity for us to fragment the ecosystem, and we don't like that. If there's something we all agree on over the last, all of the presentations is we all hate fragmentation. So I think all of this is opportunity for fragmentation unless we do something about it. And I think that's what I'm trying to say. And this is where the problem metabolizes and becomes extreme is we have MCTP, right? Life is great. But the problem is you have MCTP over 1,000 different things. I think we brought up the idea, I think Ed said, yeah, we don't like I2C anymore because it doesn't, the SI issues are, what for the future at least, is going to cause issues with going across the rack. And that's fair. And I2C has other problems, right? For example, how do you do PLDM events without doing multi-master mode? That's a big problem. And even if you do multi-master mode, what if there's a mux in between? The BMC has to go and set the mux so that it can get an event. How does that work? How do you get an asynchronous event if you have to set the mux to get it? That doesn't make sense. So, well, there is I3C, yes. I3C solves the problem with IBIs, right? And the hub technology. So it does make a step towards solving that problem. But then you can have one BMC. I mean, there is only so many I3C port that the BMC has. So you'll have to hub it. Once you hub it, there goes your performance. And then as soon as you do that, I mean, you want all the telemetry coming out, but then I3C is going to be a bottleneck. So now what do? You go for USB, right? And USB seems to be ticking all the boxes. And I think I was talking to Ed offline and we were saying, yes, USB is we all agree that USB is the thing for the future, except it doesn't exist today, in my opinion. It exists in abstraction. It exists in specifications. There you go. But there is no, between all of the hardware vendors combined, there isn't a product that is out there in the market. Yes, there might be things that are announced, but there aren't products out there except maybe the NICs. The NICs are the exception, and NICs are usually the ones leading the forefront in this. And except the NICs, I think if you look at the CPUs, we are culprit. We don't have a USB product today. If you look at GPUs, there isn't one in the market today. Okay, but yeah, it's not native though, right? Yeah. No, I do agree that the ecosystem is possible, right? I think I'm just saying that from a BMC perspective, and here when I say we, I mean BMC, I mean OpenBMC. That's what I'm trying to say is when a BMC has to manage 20 or so of these devices, hardly one or two of those will have USB today. That's all I'm saying. So if I were to design a minimalistic architecture just relying on USB, I wouldn't pretty much connect to anything. That's all I'm trying to say. And so I think that's a problem. And why is this a problem? Because we need that many more drivers to be supported in our BMC. And anytime there's a driver, there's going to be a crash. And anytime there's a crash, the BMC goes down. And we don't want BMC to go down. That's the last thing we want. So I think, and again, it's a simplistic view, I agree, but it's a goal to march towards. Now, if you go from MCTP over MCTP, it's even worse, right? We all agree PLDM is the answer to every question that we ever ask. But we do. but not everybody does, right? If you look at the NIC arena, they have NCSI and they live by it. If you look at the storage arena, they have NVMI and they live by it. They live and die by it, to be honest. And all vendors have vendor-specific extensions. And I'm not saying necessarily that's a bad thing. Actually, I agree with Ed in this, that it's a good thing. But I think from a minimalistic approach perspective, if we need the BMC to be able to boot your device, then that much should be achieved without being vendor specific. I think that's the goal that we should all have. Same goes with RDE. We have RDE. I know I called out RDE, especially outside of PLDM, because I don't know why it's called out within PLDM. It's a special thing by itself. Ethernet, I think there was a question, why can't we do MCTP over Ethernet? And so, yeah, we can do that. And then there is SPDM, we talked about it. And in the CXL arena, there is CXL CCI. So all CXL devices have to natively per spec support CCI mailbox. And so that's another thing that the poor BMC has to support. Memory devices have SPD. And if you're not bored by this whole list, the DMTF is working on, for all PCI devices, something called PCI-MI. Yet another spec. So I think there is fragmentation, whether we like it or not. We have to accept it, and we have to understand what we can do about it. I think we have to figure out what we can do. Again, harping on the multi-device problem, a single BMC in more or less cases manages multiple devices, not just single kind, but different kinds. And it also manages other BMCs, as was said before. Then at the same time, we have this KPI problem, right? OpenBMC is not an RTOS. Can it take performance targets? Of course. But can it guarantee under all possible situations that you will always, no matter what happens, no matter if it's lights out, you will be able to query 20 sensors per second? Absolutely not, right? So I think those are the KPIs. I think, and we need to be cognizant about it. Today, if you use I2C, I think a typical firmware update scenario would be in order of minutes. That's not acceptable, right? So, right, and I think Ed also touched upon this before. I think a lot of people did, where we said, yes, a lot of having another BMC hardware or scaling to a much faster or much more expensive hardware is not the solution. I think a lot of these problems are related to software optimizations. And that's a great acceptance from a team of software engineers that we are the problem and we can solve it. I think that's great. So looking at a more powerful BMC is not an option. I think, so how do we solve it? I think all of these are problems, right? And we can't boil the ocean. So what's the solution? And I would hate to say it, but I don't think we have a solution per se. But what we could do is we could start by saying, we can't do all of this, right? We can do some of it sometimes, right? Depending on the very specific scenarios that a particular system has. But at a minimum, if the goal of a BMC is to bring things up, we need to choose a few things from here and say, this is what all devices at the very least should support, so that we can, a standard BMC can bring things up. And it's priority 0, it's goal number 0, right? So I think that's the idea. Any questions before I move to the next slide? All of them. To repeat the question, I think you're asking if fragmentation is a problem. I think I don't view problems as something that we have to live with. I think problems are an opportunity, truly believing that. So what do we do about it is the question. I think that's what this slide is intended to say is, here are the things that we need to go fix, right? And yes, it's the problem is all 4 of these. And I think they stem from different areas. They don't isolate themselves to operations and specific areas, but they are there and we have to solve it. I think that's really what it is. You want to cover this?
this started. So, kind of a foundational idea of what we've been talking about between ourselves, preparing for this, is, and I feel like a lot of the discussion so far today has kind of gone in line with this a little bit of what should a BMC do well. So I had a comment earlier that I had forgotten, but I put a little note in that said, as all of these features come about, people start to view the BMC, and not just within this team. I think it's even people within our companies start to view the BMC as this beautiful big hammer that can hit all the nails in the world. And any problem that happens to come up, well, sure, the BMC can solve that. So, and maybe it can. I think it can. But the idea is there should be, if we can come up with a core set of things that the BMC does really well and that always just work, then I think it gives us a head start on mixing hardware. So I know Ed talked about increasing hardware complexity. We've talked about some of the increasing spec complexity. If there's a minimal set of things that we say this is what the BMC does, and it does it well, and if you put the BMC into this situation, it's going to just work. And that's kind of what we're looking for. What is that? And I don't know if we've come up with what that is. And that's part of why we're looking for a discussion with the community of what does that look like? And then I don't know if you're going to bring this up, but Nirav said something that I really liked, which is if we can come up with something and write it down, then this is something that we can take to a silicon vendor or a platform vendor. And we can say, if you follow these guidelines, the BMC will just work. And then all the other stuff, we have lots of time now for innovation because we've saved all that time and effort on this core set of things that are just going to work.
And even if you were to zoom out and look at it from a product standpoint, I think there are two divergent views. I think there is this constant need for vendors to innovate and look at BMC as a way to distinguish themselves, and so the vendor-specific code, right? At the same time, the integrator's problem of having vendor-specific code that they can't integrate now, right? So I think it's a classic. He wants that. He wants the problem. The way we solve it is we find something in the middle, right? We say that, yes, the device vendor should have an opportunity to innovate. Yes, there should be a minimal set that should just work. And something like BMC, it's table stakes. It has to work. I mean, going back to our DNA, what BMC is all about is lights out management. When everything else is not working, BMC has to work, right? Because it is the one that's going to prevent and recover. Right. So I think stating that mission down with the goal that we want to define a BMC that is minimally working with everything out there. Right. This is our call to action to you guys. This is what we want to work towards. Help us. We have some areas of focus that we have nailed down. These are not written in stone. We appreciate feedback. I think if you want, we can talk offline about how to take the next steps, whether it's through a design document in OpenBMC, whether it's to go and write yet another spec, or whether it's a white paper that just gets published somewhere and lets people know this is what we as the BMC winners, this is our direction to the industry.